Alright, hope everybody's enjoying their Wednesday evening. Just wanted to record a few pre-cal videos. So the first problem is over here on the right. It says limit as x goes to 5 of square root of x minus 4 over the cube root of x squared plus 2. Upstairs we have a plus 2. Downstairs we have a minus 1. Folks, anytime you have a limit problem, step 1 is plug in the value. So we get square root of 5 minus 4 plus 2 over cube root of 5 squared plus 2 minus 1. 5 minus 4 is square root of 1 plus 2 over the cube root of 25 plus 2 is 27 minus 1. Square root of 1 is 1 plus 2 is 3. Cube root of 27 is 3. 3 minus 1 is 2. So limit as x goes to 5, square root of x minus 4 plus 2 over the cube root of x squared plus 2 minus 1 equals 3/2. Don't assume every problem is either rewriting, multiplying by the conjugate, or factoring. Some of them will just be able to be solved by plugging in the value here. So ensure you're at least trying that every single time. Alright, there are two more problems I want to do. These were requested to me. The next one is on page 3. This is top of the page. It says selected values of the continuous function g are shown in the table below. Let me graph these. So I get my picture here. I have 0, 1, 2, 3, 4. Then I have 2, 1, 3, 4, 5, k. I don't know where that is. And then I have 7, 3. So here's what I've got so far. And it's saying if g, this is what I've got so far. And somewhere over here, I know I have the point 5 comma k. Right? That's somewhere at 5. And it says if g has one root from 2 to 7, 2 to 7, if g has exactly one root from 2 to 7, then what can k not be? Well, just plug in here. If k is negative 1 right here, if k is negative 1, that means I have the point 5, negative 1. 1, 2, 3, 4, 5, negative 1. How can you draw this? Well, there's a lot of ways, but if it's continuous, it has to go down and up and have two roots. That's not possible. Because the question says, if g has one root, then what can k not be? K cannot be negative 1. Because if k is negative 1, we have to have two roots. So the answer is A, k cannot be negative 1. And finally, the last problem that was requested was the one right below it. It says the function is continuous on the closed interval negative 5 to 5. The first thing is I have a point negative 2, 1, 2, 3, 4, 5, 6. Again, I'll show you my picture in a second. I have 1 comma k. Don't know what that is. 4 comma 3. 1, 2, 3, 4. 1, 2, 3. So here's what we've got with regards to the picture. And it tells me it must have two zeros if k is equal to which number? Well, if k is, so the possibilities for k are 0, 2, negative 1, 6, 1. 0, 2, negative 1, 6, 1. If k is 0, that means it's here. This could just have one root. And they're asking me which one has to have two roots, so that's out. K could be 2. That would be here. That's out, because that has 0 roots. K could be negative 1. 1, negative 1. Ah, here we go. Because again now, you got the two roots. Because you have to go downstairs and then back up. You know it has to go this way because it's continuous, which means the answer is negative 1. If k is negative 1, we have to have two roots. Hope these videos were helpful, and I will see you all tomorrow.